Everyone, Ings here. And if you are one of those guys who think multi-threading is really fast and async single-thread applications are slow as hell, and that's why you always say, oh, Node.js is really slow, it's not good as compared to something like Spring Boot, because Spring Boot is multi-threading and Node.js is single-threaded, and you say I can't run multiple processes simultaneously in single-thread applications, then I'm here to bust some of your myths. This is part one of the architecture of how does async and multi-threading and parallelism or concurrency works. So I will making some of more videos if I get time. So this is the first video where I thought of explaining and busting some of your myths around async architecture. I know that many of you guys know that async is resourceless heavy, multi-threading is can be resource heavy, but I'm sure that many of you don't really know why async is resourceless heavy, why multi-threading can be resource heavy. Okay, many of you might say that in multi-threading I have something called multiple threads, that's why. Alright, but let me tell you, in async you can also have multiple threads. We have a concept called thread pool where we have one main thread and we can use other threads to offload our heavy IO works. Okay, let's go into those things in future, but let's go into this thing in this video. So many people think if I've used await, I am calling a promise, then my main process is blocked, my main thread is blocked. If many of you know that is not true, then that's good. But if you guys think that if I have added await and a promise, then my process won't get my main application logic won't get to the next step, then this video is for you. This video is going to be as small as possible. I'm just going to show you this example function which I have wrote, and I'm calling this is the main logic. So this is the main application logic. In this main application logic, I have one single thread. So I'm calling before calling fetch user data. Of course, it should get printed first. After that, I'm calling this promise fetch user data 1. This is a async function. I'm using a console log here. I have a await function here. So after this logs, this should get logged, correct? And my this function should not get logged. If you guys think that my using await my main function is blocked, okay, as a result of the complete function. As you saw, the before calling fetch user data gets called, of course. After that, I call this function, this gets logged, correct? After that, this statement should get logged because I'm using await and this should be logged here. But instead of that, my main thread is free and my console is getting to this statement, and after that I'm getting an error from this statement and it gets logged. That tells you that using of something like await, what I'm doing is I'm not blocking the main application logic. In fact, I'm just telling that inside that process in the main application logic, wait till here, only process after that. And now I write await here. Now what happens? Does my this statement still gets executed after, even after this is making an API call, or does it wait? Let's see. As you can see, it is waiting. What does that mean? So what I've said was wrong? Does that mean that my whole idea about async being good is wrong? No. Look, it's very important how you design your softwares. It's very important how you maintain your application processes. That is why async is called something software managed, software intervened basically, and multi-threading is called OS intervened. In OS, I can achieve a similar thing using what I can achieve in single thread applications but with background threads from thread pool in Node.js. But that won't be true multi-threading. Reason about that is because there is no context switching happening at the OS level. Context switching is happening by something called OS level. And what does it even mean? It means that my threads are being exchanged with context by OS management, not with the software developer management or software interventions. So in this case, is my main application logic is blocked with await? That is not true. The reason about that is because this is a simple process. In a main application, we usually don't have simple processes. If my process is single threaded, that does not mean it's slow. I can still achieve something called concurrency with these kind of logic, where my first process gets executed, second gets executed, and inside I have this one another process. This another process is asynchronous. I wait some things inside that process, but that does not block my code. So in this fetch user data, I was awaiting here, and this process was awaited, this process was also waited, and this was logged only after that. But that didn't mean my thread is blocked. I can still achieve this statement, and I can still achieve this process. So single thread is really good, but it's very important that how you design it. That's why we call single thread async architectures as software intervened architectures. Multi-thread architectures are called OS thread intervened architectures, because in OS intervened architectures, OS manage the context switching part. But in single thread async architectures, you need to design it better to smartly handle the switching between tasks in concurrent processing. So event loop is responsible for this, and you give control to event loop. So for example, here after I ran this statement, here I gave control to the event loop. Okay, this is my blocking operation and I want to run it asynchronously. Okay, my event loop said alright, then I will execute the next step, which is non-blocking. So async is really simple, and Nodejs is really cool to scale. I will give you a lot of examples in future. See you in the next video. Bye bye.